Good afternoon. In the previous video we talked about the digital outputs, digital inputs, group outputs, and the other outputs and inputs that a robot system can have. In this video we are now going to do a little bit of programming with the digital outputs, digital inputs, and simulating a PLC to an actual robot. So right here I have a setup of a basic cell that you would typically see. We have a conveyor belt with some sort of suction device with the end of arm tooling on our robot, and then we have a pallet in which we're going to stack the items that are coming down the conveyor belt onto the actual pallet. Now we're not going to do all the picking up and moving over. We're going to just again simulate more of the digital ins and outs to the actual program. So right now I have set up a couple different types of outputs. So this is a digital output. We're utilizing digital out 1 through 16 in 8 different sections. If you remember last video, we set up the rack, slot, and also starting points and ending points of each of those slots and racks. So on our digital 1, we're going to have a robot ready. So this is going to be yes, everything is good, robot's ready to move. Then we're going to send out a digital output for robot at home, robot at safe position, robot at pickup position, robot at drop-off position. So we can talk to the PLC and tell it exactly where the robot is so the PLC can make decisions based on those movements. Anytime that the robot is going to be in movement or moving, we're going to have a robot in motion command send out as well. And we also have a couple outputs to the laser. So we're going to say that there is a laser pointer on top of the end of arm tooling so that we can correctly line up or scan something. Maybe it's a box scanning item, who knows. So it's just a simulation of a laser output. And then we're also going to have also a output of vacuum ready. So we're going to have a output from the robot to your system, and then this is going to send out a signal to the PLC saying that, hey, the vacuum is ready or vacuum is good, so that we have an indicator light or some sort of screen light saying that vacuum is good. So there's a couple different outputs that we can have. Again, an output is a yes or no, is it good? Next is the ins. So on the ins, we're going to have a PLC hooked up. So I'm going to just pull up my PLC. So just a programmable logic controller. Again, this is not actually hooked up to our robot system here. So I have this under simulation. So when I actually push the red button, I can actually simulate it as off. So example would be simulate off, simulate off. Okay, so we can simulate off when we press that red button. Okay, same thing, we can simulate on and off for the laser. So on, off for the laser button. So example would be, this will be considered a laser, so that would actually turn on the digital input. Okay, so this PLC right now is talking to this simulated, so we can determine, okay, from our laser input, we can now put a output to the actual laser to turn it on. Now, the only way you can change your status of your numbers to on and off is to actually make it simulated. So right now this says unsimulated, so if you click it, you'll see simulated, unsimulate. So I can simulate this, or I can unsimulate this. Now, never want to simulate something on an actual device unless you know that it's not going to break anything or run the robot into any problems along the way. So a good way to make sure that everything is unsimulated is if you go to function and down to the number 6 here. So if we go to next, there's unsimulate all, and that unsimulates everything. And then you have to go back through and then simulate all your different devices. Don't have the time to unsimulate things, just go to, again, function, and number 6 is going to unsimulate things. So next, we're going to have our digital ins, digital outs. Let's go to our robot outputs. So on our robot, we're going to have a device coming out to our end of arm tooling, and we're going to have 4 vacuum solenoids. So 4 vacuum solenoids are going to be hooked up to this, and that robot output is going to turn on those vacuum solenoids or enable those vacuum solenoids. Right now they're enabled as off. Okay, so when we come down, we have to turn those robot points on so that the vacuum will actually pick up the box. So that's going to be our output, and there is one input which is vacuum ready. Now we don't have any analog set up. We don't have any analog devices set up. We don't have any group setups at this present point, but we will set up some groups to make our life a little bit easier. So let's start out pretty simple. We're going to allow our push button or our turn knob of our PLC to turn on the laser, which is at the end of arm tooling, which will be wired through our robot system and won't be actually wired up to our end of arm tooling, just so that we have something to program. Okay, so let's go create, and I'm going to call this laser exit. Now, this is where a lot of people will jump right into the actual program, but they'll forget a very critical step. If there's absolutely no robot motion in this program, we want to go into detail and change the group mask to nothing. So that means there is no motion that is happening. Now, if we don't do this, this will not allow us to do certain things down the road. And now, you can program this as a 1, but again, there are certain things down the road that you will not be able to do that is important. So you want to make sure you turn or disable this item. So then I'm going to go previous. So now we are in the actual program and the actual item is off. So inside our very simple program, we're going to bring in our digital outputs. Now, to make this easy so we don't have to keep jumping to the screens, let's go to our edit and bring us back to the program. Let's split this screen. So let's go to Shift Display, then let's go double. So now we have 2 screens, and let's click inside this screen and then turn on our digital outputs. There we go. And then go to digital. So now we have all our digital points. So we're going to look at a digital in, which we're going to utilize that turn key. Okay, so let's switch to digital in. So we're going to do laser button is number digital 3. The first thing we want to do is we want to make sure that everything is off and initialized. So I'm going to initialize my variables. So I'm going to insert probably about 12 lines here so I have space to work. So I'm going to go miscellaneous and I'm going to go remark, and this is going to be my initialization. So we have our variables. So we're going to turn off our digital device. So we're going to instruction, IO, digital out, and let's look at the digital outs. Digital out number 7. So we're going to switch this to number 7. And then we're going to make sure it's off in the beginning. Okay, so now we have our variable, which is inputted, and the inputs are always going to be yes or no. So it's really determined on what is the input of your button or the key, so we don't really have to initialize that in the start. Okay, so then I'm going to have a loop because I want it to continuously check whether that button is being pressed. So I'm going to do a label, and this is going to be my label 1. Then once we're in label 1, we're going to see if that button is pressed. So we go new instruction, if select, if equal to, and then we can do digital in. So if digital in, and let's switch back to digital ins here, if digital in of button 3 is on, then we want to jump to label, we'll say 2. So we'll jump to label 2. If not, continuously loop here over and over and over again. So I'm going to just do instruction and jump, and we're going to jump to label 1. Okay, so it continuously checks to see if it's pressed. If it's pressed, then it jumps out of this loop, and we'll go down here and we'll call this the label 2. And then inside label 2, we're going to turn our digital laser on. IO, digital of the laser is number 7, and then we're going to turn it on. Once we are on, we will need to check to see if it's off again, so let's do another if statement. And we're going to jump to label 1 then. So if it's off, then we jump to label 1. If it's not off, we'll continuously make sure it's on. So I'm going to go inside here and we go jump to label 2. So if it's not on, okay, so if it's off, if we press it off, then we jump back to label 1, but if it's not, we're going to turn it on. So, but we need to go in here, we also need to turn something off, just in case. So if we go back, otherwise it remains on. So I'm going to insert one line, and then I'm going to turn my digital output off. Alright, so let's try this out. Okay, so right now it's just staying at label 1 because it's looping, looping, looping. Again, it's looping so fast that we don't actually see it go through. There is actually no movement instructions, so it just jumps literally in thousandths of a second. But as soon as we do our digital input, if I go digital input laser, if I switch this from off to on, you'll see it move down to here. So there we go. So now it is on. And if I go to my digital outputs, notice how my laser is simulated on. Okay, so let's actually go to 3 windows here. So Shift, Display, Triple. So now I have 3 windows. Let's go down here and let's put our digital inputs. So IOs, and then let's switch to our digital ins. There we go. Alright, so we can see our laser on. We have our push button on, our laser on. So if I turn our laser button off, notice how our laser goes off. On, off, on, off. Now again, this is a roundabout way of programming a digital in and digital out. There are better ways, and we'll do that in a different video and talking about the different if statements and the select statements if something happens. But this is just a quick way of doing things if you don't know much about programming. So just kind of show you again. So this is my laser, which turns on the red indicator light. So as soon as I press it, now you see the laser is on. So going to the digital output number 7, laser's on, and as soon as I go over, I turn it off, and then the laser is off. So on, off. So that's how you would communicate between a PLC and the robot interface with a digital out and digital in device. So this, you would have a digital out to our robot, and from the robot you will have a digital out where you will have a digital in here. So it's always opposites. Now what's nice about having just the laser program here, and we have it as a grouping of no motion groups that we did in the beginning, is that we can run this as a macro or a program running parallel to our programs here. So we can always turn on, turn off the laser no matter where we're at in the actual program. Alright, so let's try something a little bit different. So let's go back to Select, go inside this window, let's go to Select, and let's create a program. We'll call it Pick Up Program. And I'm going to enter. So this one we do have a motion group because we are going to move our robot. So I'm going to do a couple different things. Number one, I'm going to set my program ready so we can send out a signal robot ready. So inside here, I'm going to set up my frames first, and then I'm going to go through my different variables. So I'm going to go ECDM, I'm going to insert a bunch of lines in this one, turn on my actual teach pendant, there we go. And the first thing I'm going to do is I'm going to add my remark, and I'm going to go inside here, and this is going to be my frames. And inside my frames, I'm going to have my offset frames, and we're going to use our utool number, and we're going to use a constant of 1, and then we're going to go we're using utool number 1 and uframe number 1. Then I'm going to go here and I'm going to add my miscellaneous and remark, and these are going to be my variables. There we go. So the first variable I'm going to send out is that the robot is ready. So I'm going to go instruction, ins and out, and we go digital output number 1, and I'm going to set that to on. So saying that my robot is ready to go, that means I picked up my program, I ran this. So that sends out to my PLC saying that my robot's ready to run. Okay? So the next thing is we're going to have this in our safe position. So we're going to turn off all these digital outputs in the beginning, and then we're going to turn them on and off as we go through. So when we go instruction, digital in and out, digital out, and we're going to do 2 through 5. Okay, so 2 through 5, turning on and off, this will take a little while to actually do. So to initialize 2 through, we'll say all the way through 8 to on and off, this we would have to do 8 different instructions going back and forth, back and forth, back and forth. This is where the group will actually come into play. So instead of the DO, let's get rid of that. We're going to create a group. So I'm going to go from this screen, I'm going to go into my ins and outs, and I'm going to go to type, and I'm going to go to group. So group allows us to actually group a bunch of digital ins or digital outs, and depending on the digital number I put in or the integer number, and that's based on a binary output of that. So let's go through what that means. So here we can turn on or off a whole list of different outputs or inputs, and this is based on a binary bit. So if I go through here, if you notice that we have digital 1, 2, 3, 4, 5, 6, 7, 8, and if we look at it as groupings, we can have up to 16 in a group. So the first one is going to be 2 to the 0, index 0, then 2 to 1, 2 to the 2, 3, 4, 5, and then each of the numbers is going to be 2 to the 0 is 1, 2 to the first power is 2, 4, 8, 16, 32, 64, 128, 256, 512, and then 1048, and so on and so on and so on, up to 16 bits, which get pretty big. Okay, but if we want to have certain bits on, for example, digital 8 through digital 0 to be off, this would be a digital number of 0. If we want to have digital 8 on and digital 5 on, 2 to the 7th power is 128, 2 to the 5th power, or 2 to the 4th power is 16. 128 plus 16 plus, if we wanted our digital 1 on, 1 gives us 143. So what we would do is we would go the group output number 1 is equal to 143. That will turn all of them on, or what we can do is group 1 equal to 0, which will turn them all off. Okay, so let's actually go in there and do that. So I'm actually going to start with group number 2, and I'm going to go in and configure group number 2. So we're going to use rack number 1, and then if I go into my digital outputs here, and I go configure, here's my numbers. Okay, so we're going to go group rack number 1, slot number 1, and we are going to start from point 2, and we're going to go all the way up to 8. So we go 2, enter, and then we're going to go all the way up to 8. Okay, so number of points is going to be 6. So starting at 2, going up to 6, because we're not including the first one, which is robot ready here. Okay, so now that we have that group set, let's go into our program and just kind of show how it works. I'm actually going to turn all these on, so that when we initialize, it should turn all these off if we did everything correct. There we go. So we turned them all on, and then I'm going to go back here, and I'm going to go back to my screen, configure, and we did number 2, and I'm going to go in here, and I'm going to rename it. So I'm going to go to the right, detail, and we go robot at digital outs, enter. Okay, so then I just go previous, brings me back, And then we can go inside here. Now, in order for this to take hold, we have to restart our controller. So I'm going to go cold restart. Okay, so I have everything restarted, and I pulled up the 3 screens again, put my digital outputs here, and I turned them all on. And then I put my group outputs here. Notice how it's now initialized. And then I have my program here. So I'm going to go inside here, and we're going to go new point. And we're going to go in and out, and we're going to do group, and we're going to use group number 2. Now if we want everything to be turned off, we're going to set it equal to 0. So that means there are 0 outputs going on. Again, that's binary 0. That has nothing to do with all of them being off. Okay, so that's 0. So now when I run this, let's try this. So if I go step mode, shift forward, so the first thing you're going to see is the digital output number 1 turn off, or turn on. So let's go in here. Let's turn this off to start out with. So I have it off, and let's go back in here, shift, step mode, go in here. So the first thing you're going to see inside here is that this is going to turn on. There we go, turns on, and then lines 2 through 8 should turn off. There we go. Oh, forgot number 8. So we need to go in there, we need to reinitialize our item. So vacuum ready needs to go back in here. So let's go in here, and let's go config. And we're going to go 7 points. There we go. And then what we have to do is power off and then power on to enable changes. So again, I have to just do a cold restart. Alright, so I changed everything. So I changed it to 7 instead of 6. I redid the off and then ons just to check it. So I'm going to go here, and I'm going to go forward, 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 forward. The first thing you should see is this turn back on, turns on, and then turns off. So everything turns off after that. So very quickly we can turn off everything based on bits. So instead of doing digital 2, digital 3, digital 4, digital 5, digital 6, to blah, 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 we can easily go through and we can change our different bits based on a binary numerical number. Alright, so the first thing we're going to do is make sure that our robot's in our safe position. So when we go to instruction, miscellaneous, and we're marking this is going to be my safe position, where it's at actually right now. But if it's not there, we want to make sure that number 1, we're moving to that safe position. So we're going to turn on robot in motion if it's not. So we're going to turn robot on in motion, and then we're going to go to that specific point right there. So we can just put in our digital number 6 for this one because it's a single item, but later on we'll just continuously use groups and the binary numbers. So I'm going to just go in here, and I'm going to go ins and outs, digital out number 6, and we're going to turn it on, which representing that we are moving to that specific position. Then we're going to go our next point. We're going to go a movement instruction. We'll go over, we're going to go point, and we're going to do a joint movement to our safe position, which, if I remember right, is position register number 3, but let's double check. So let's go to data and go to type position registers, and I have a couple of registers here. So safe position is position register number 2. So when we go back to edit and we go to choice, position register number 2. And we're going to go there, and once we are there, we want to turn our digital output number 6 off, representing we are not going to be at that position, and then we want to turn on our safe position. So I have here in Excel, I created a very basic chart that says robot at home position, safe position, pick up, drop off, in motion, on off, vacuum. And I can put in the bits. For example, I want to be at the safe position, so that would turn that on, and we want our robot in motion off. So that's what's nice about the group, is that you have one or multiple on, but it turns off the rest of them. So with this bit on, our binary number is going to be 2 to the first power, which is 2, and being 1, so we add that. All the rest are 0, so that means we're going to put in a digital output of 2 for our robot. So I go back here, and I'm going to do a group output, so instruction in and out, group output of number 2. So our group output number 2, and we're going to set that equal to 2. So that means that our at point safety position is on, the rest is off according to our chart. So 2 is our output. So I move the robot out of position, so it's not in safe position right now, so you should see the digital on go on, and then it goes off afterwards. So I'm going to go shift, and I'm going to turn on step mode, and I'm going to go forward, which clears everything. And then it should turn on. So there we go, robot in motion. It's going to go to motion once we're at that position, then goes off, and notice how it says robot at safe position. Okay, so to show that in actual motion here, I'm going to move it out of the way, and let's actually run this for real. So I'm going to actually move it pretty far away here. So say we're picking something up over there. Okay, so I'm going to go up here, I'm going to turn off step mode, and then I'm going to run it for real. So watch the on and offs there. In motion, and then the robot is at safe position. So next let's go to our output here. So I'm going to go here, and I'm going to go instruction, remark, and this is going to be my pickup area. So there's pickup. So when we're pickup, we want to turn on motion. Okay, so turn on motion, and we also want to turn the rest of the items off. So I'm going to use the group output, and we want to be in motion. So I'm going to turn this from 0 to 1 because we want that to be off, and we want in motion to be on. So I go here. So that means we need to put in equal to 16 so that all the rest are off and the robot in motion icon will be on. So I'm going to go back to my robot here, and we're going to do a group in and out, group, and we're going to go group number 2, and we need to set it equal to 16, which will turn off everything but the robot is in motion. So just kind of show that. Step mode. There we go. So all items are off but robot in motion. So we're going to be in motion to our point registry down below, but we also want to have a safety position so it comes down. So what I'm going to do is skip one row here, and then I'm going to put in my point registry movement here. So I'm going to go down here, instructions, and this is going to be instruction number 3. Oops. So point, and we're going to go there as a linear movement, and this is going to be my point register number 3, which should be my pickup area. Then from there, so let's actually go to that position. So we're at that position. Then what I'm going to do is go one line up. I'm going to click my tool. Okay, or I can switch my coordinate system to tool, and then we move it up into position, say maybe -500 here. So it's out of the way. And then I'm going to do a jump to position, which is going to be use a joint. So I'm going to go joint down to this position right here. So that's my safe position. And then it's going to linear down at, we'll say 500 millimeters per second down to our position. Okay, then once we are at position, then we want to turn on at pickup position and then turn the rest off. So I'm going to go here, and I'm going to go, let's go, and we also want to turn on our vacuum ready. So let's go 0 here for the motion. We're going to be at pickup position, and then we're also going to turn the vacuum on, or vacuum ready. So 4 plus 64 gives us 68 as our number. So the rest, again, is going to be off. So I'm going to go back into our device here, and I'm going to switch over to instruction and ins and outs, groups, group number 2, and then we are going to set it to a constant of 64, so which turns off all our devices but for our vacuum ready and then our pickup. Let's do the same thing for our place. So I'm going to go miscellaneous, remark, and then here's going to be our placement, and we're going to, once again, in motion, so I can actually copy this if I want to. And then paste it down here because it's the exact same thing. Okay, so we're using digital out 16. We'll turn off everything but robot in motion. Then we're going to go down to our position. So let's go down to position. So go in here. And we're going to go point. We're going to do this as a linear motion. Let's change this to 500 millimeters per second. And then this is going to be point register number 4, which should be our drop-off position. So let's actually go to that position. Let's do a safe position for line 22. So I move it up my, say, negative 500. There we go. And then I'm going to save this as my safe position. So I go point, and I'm going to do it as a joint movement. And then I'm going to go in there, joint, linear down to there, and then once I'm at this position, I need to turn on that at position. So we're going to turn the vacuum off, and then we're going to be not at pickup position, we're going to be at drop-off position. So 1 and vacuum off gives us just 8. So I'm going to do my group output. Number 2, and we're at number 8, so that everything is off. Now again, we probably want to go back up to our safe position, so we probably should add that safe position item on there, but again, you get the point. We're just showing the digital ins, digital outs. I will pause the video to do an actual add the inputs and outputs of that. So let's try this out. Let's go to run and watch the inputs and outputs. Turn off step mode. So in motion. There we go. So now we're at drop off, and then we're at our different points. Alright, so I just went in here and cleaned it up a little bit. I added some positions. I also swapped the vacuum on and off, so that's on when it's running and then off when it's going. So I'm going to just run this program to show you what it looks like when it's on. Okay, so you can see all the digital outputs here, and that could be simulations on a screen of your PLC to tell you what position the actual robot is on. You can see if the vacuum is on or off. You can see if the laser is on and off. You can also look at the digital outputs here. Notice how that binary number has changed as we go through each of the different scenarios. Okay. So you can see very easily you can set up a group to control a multitude of different digital outputs and inputs, so you don't have to continuously turn on and off and on and off and on and off a bunch of different outputs and inputs, and you could do it with just one binary number of a group output. And again, I strongly encourage you to do something much like this on an Excel sheet and save it somewhere near your actual robot cell so that you can easily put in, okay, I want to be at home position, and this is just again multiplying this number by this number. So if I actually look at the cell here, it's just these two numbers multiplied together. Okay, and then this is just, you know, to the second power, or to the first power is going to be 2, 4, 8, and then you can continuously add on as many as you need, and then this is just summing this entire row together, until you have the actual number, and this is the number you put in on that group. So depending on what you want, if you want them all on, just go right down the line and put ones all the way down the line, and then your total number is going to be 127. So that's utilizing digital ins and outs. You can add more to this. For example, you can do wait for a digital input, which is a push button. You can wait for a toggle switch. So there's a whole multitude of things you could do with digital ins and outs. I know we didn't do a lot with the digital ins. We did a lot more with the digital outs and the groupings, but basically it is the exact same thing. Okay, so later on we'll talk a little bit more about logic with if statements and if then to make programming a little bit easier, but this is basically the premise on our group outputs and group inputs. Again, we also didn't talk anything about our actual robot outputs and inputs. Right now we're just saying vacuum on and off without actually turning the vacuum on and off.